Now in this lecture, we starting the mathematics operation that can be do with the help of NumPy. But math can be scary for some of your people, but it is not scary in this NumPy case because it is straightforward. So let's get started. So first of all, let's define an array. So ARR and NumPy dot array of one dimension array. So 2, 3, 4. Now we have an array that have only one dimension data 2 3 4 5 2 3 4 6. Now let's do first operation, which is we divide b plus all the element of our array with 2. So the resultant are, as you know, 4 5 6 8. So 2 is added to each element of our array. Now let's do same with subtraction. So 2 is subtracted from all the element of our array, so we get 0 1 2 4. So subtracted from all the element. Now same thing happen from for multiplication, like this one. So each multiply with 2. Same with division, each divided by 2, so we also get the point value or decimal value. So these are some basic operations. Now we have trigono operation also. So cos, so we find the cos functions of our array, so we get our cos values. We also get our sine value, and this is just a mathematical high school mathematical basic knowledge of cos and sine trigonometries. So we get our sine and cos functions also. So these are some basic mathematical operations we can do with the help of our NumPy. So yes, after applying this cos function, our array is changed in the memory, so we get something like that or not. Yes, it's so let's find square of our elements. So we get 4 9 16 36. So we squared over each element. Now let's do operation between two separate NumPy arrays. So we have array 1 as defined here. So now do array 2 NumPy dot array and just use different array. So 8 9 7 0. So we get this one. So let's add this both array 1 plus array 2. So each corresponding element added. So for example, 2 added with 8, 3 added with 9, and 4 added with 7, and similarly 6 added with 0. So we get 10 12 11 16. Now same thing happen after minusing. So each corresponding element of both arrays are subtracted. So we get minus 6 minus 6 minus 3 6. So similar thing happen for so let me clear all the things so you get how this operation happening. So array 2 is this and array 1 is this. So the operations between happening these two. So 8 multiplied by 2 16, 9 multiplied by 3 27, 7 multiplied by 4 28, and 0 multiplied by 6 0. And same this divide. So we get 2 divided by 8 because we dividing array with array 2. So here. So 2 divided by 8 0.25, 3 divided by 9 0.333, and this values continue. 4 divided by 7 0.571, something like that, and 6 divided by 0, which is infinite or not defined, because anything that divided by 0 is infinite, or it's zero divisible error in some case. Now these are some basic operation. Now in deep learning, we generally tackle lots of matrix, as we known earlier. So we want to do lots of matrix multiplication or pointwise dot product of matrix. And let me revise you how the dot product of matrix actually happens. So here is the slide I prepared, a short slide. So if a matrix A have a row L, means 1 2 3 4 5 L rows, and M columns 1 2 3, and then another matrix have M rows like 1 2 3 and N columns 1 2 3 4. So when we do point-wise multiplication of this both matrix, we get another resultant matrix which have L rows and N columns. So the column of first matrix should be equal to the row of second matrix. So as you can see that M and M, and the resultant matrix is of L and N. So this is the straightforward use thumb of rule or rule that the column of first matrix should be equal to the rows of the second matrix, and we get the similar matrix like that. So let me show you that what I'm trying to say. So let's define matrix 1 numpy dot array, or two-dimensional matrix, or 2, 3, 4, and so we have matrix 1 of 2 comma 3, or 2 row and 3 column dimension. So we have a shape 1, 2 or 3, or L equal to 2 and M equal to 3. So in this case L equal to 2, in our case L equal to 2 and M equal to 3. Now let's define another matrix, matrix 2 of shape. Let's define one more shape to obey this rule. Now the matrix 2. Now the shape of second matrix is 3 comma 2, or 3 rows or 2 columns. So let me print the matrix 2. So we have 3 rows and 2 columns. Now the L in this case is 3 because we have 3 rows, and M in this case is 2 because we have 2 columns. Now when we multiply this matrix 1 and matrix 2, or 2 3, or 2 comma 3, or 3 comma 2, like this one. So if we multiply L into M with L into, if we multiply L comma M matrix with M comma N matrix, we get L comma N matrix, or L rows and N columns. So in this case what we get is 2 comma 2 because L is here is 2, M is 3, M is here 3, and N is here 2. So when we multiply this, we get 2 comma 2. So let multiply this both matrix. So to multiply this, we need to use a function. Want to multiply this both matrix and obey this rule, this dot product rule. What we need to do is apply numpy dot matrix multiplication, or matmul, just a short form, and specify our both matrix. So in this case matrix 1 and matrix 2, and we get 2 by 2 matrix of the resultant value. So that's the rule. If our first dimension matrix is L comma N, or L rows and M columns, and our second matrix is M comma N, or M rows and N columns, our resultant matrix is L comma N, L rows and N columns. So we get 2 by 2. So you can also assume from this or this. Now how this matrix multiplication calculated? Here is the another slide. As you can see that the first matrix have 2 comma 3 dimension of 2 rows or 3 columns, similar to us, row 3 columns, and second has 3 columns and 2 rows, again similar with us, 3 column and 3 rows and 2 columns. Now how matrix multiplication happen is, we take one row from first matrix and first column from second matrix, and we multiply this point wise, or their corresponding position. So for example, we multiply 1 with 10 like this, we add this, we multiply 2 with 20, we add this, we multiply 3 with 30, we add this. Now we take this first row and now this second column and repeat the same procedure, and now same for this second row, we take this second row and this first column, repeat the same procedure, second row and this second column, repeat the same procedure. After doing all this calculation, we get our resultant matrix. So that's how the point wise or dot product of matrix multiplications happen. And this is also same thing happening behind matrix 1 and matrix 2. So that's the case I want to show to you and demonstrate you that how this matrix multiplication happens in NumPy, and this also happen in our neural network. This is very crucial concept in our neural network. Generally our neural network has 2 to 3 very crucial mathematical concepts. First is matrix multiplications, second is derivatives, and third is statistics or backpropagation or derivatives. So these are the core concepts of our deep learning neural network. So that's why we need to make our fundamental understanding in this concepts clear. So that's why I made this two small slides to demonstrate you that how matrix point-wise multiplication happen. So that's all for this tutorial, guys, and I hope you get the intuition that how this matrix multiplication, and generally this is called linear algebra. So that's why this point and to be noted, this is called linear algebra. So that's how we tackle some of the basic mathematical operations in our NumPy, and a basic linear algebra, matrix multiplication, or pointwise multiplication concept. We clear this concept or revise this concept and apply in our Numpy. So that's all for this tutorial, guys, and I hope you get the intuition. And if you have any doubts or queries, you can ask in the comment section. My team and I generally try our best to take our time from our schedule and give and suitable answer to your question. But anyways, so okay then, bye bye, and keep learning artificial intelligence.